In this video, I will show you how to find a confidence interval given the sample mean, standard deviation, and sample size. A company that produces white bread is concerned about the amount of sodium in its bread. The company takes a simple random sample of 500 slices of bread and computes the sample mean to be 125 milligrams of sodium per slice, and the standard deviation to be 15 milligrams. If you want 98% confidence, find the interval that contains the mean sodium content of all the slices of bread produced by the company. So we're going to use this formula to calculate the margin of error if you want 98% confidence. This is the formula that you would use. Now, actually, this formula can be used for any confidence level. The key is the z-score. So you would be given a chart like this that will tell you the z-score to use for whatever confidence level you're interested in. So we want a 98% confidence level. So there you see the 98. That tells us that we're going to need to use a z-score of 2.33. So that's the first thing we will do as we calculate this margin of error. So we've got, okay, plus or minus 2.33. Now we need to deal with the standard deviation, which goes in the top, and then the square root of the sample size. The standard deviation is 15 milligrams, so I'm going to put the 15 right here. And now the sample size, they took a sample of 500 slices, so the sample size is 500. So I'm just going to put this in the calculator and see what the margin of error is. So 2.33, 15 over the square root of 500. So I get this. Now I'm going to round to 1 decimal place. So that means I'm interested in cutting it right here. Now remember, if the next number is 5 or higher, I need to round up. So this 1.5 will become 1.6. So plus or minus 1.6. Now, that's my margin of error. To get the interval, I need to look back at the sample and see what was the sample mean. How much sodium was on average, was in the sample of 500 slices? Well, the sample mean was 125 milligrams of sodium. So what I'm going to do then is take this margin of error, all right, this sample of 125 milligrams of sodium tells me that the population of bread, if I looked at all the bread produced by the company, it's probably going to be pretty close to the sample, but it could be a little bit higher or a little bit lower than what the sample said. So that's where the margin of error comes in. So I'm going to start with the results of the sample, 125 milligrams. Now I can add 1.6 or subtract 1.6 to find out how much lower and higher I might need to go to capture the true percentage, the true average sodium content for all the bread produced by the company. So when we make an interval, we always want to go least to greatest. So I will first subtract 1.6 and then I will add 1.6. So 125 minus 1.6 is going to be 123.4. Okay, milligrams. If I add 1.6, that's going to be 126.6 milligrams. So we wanted a 98% confidence interval, and here it is. We can be 98% sure that the actual sodium content, the average sodium content of all the slices of bread produced by the company is somewhere between these two numbers.